In this video, we are going to learn about Julia set, which are fascinating fractal patterns that are generated from complex numbers. What are Julia set? Well, they are named after French mathematician Gaston Julia, who studied them in the early 20th century. He was interested in the behavior of complex functions. One of the simplest complex functions is the quadratic function, where z and c are complex numbers. For example, the orbit of z equal to 2 plus 3i is. As you can see, the orbit of z grows very large very quickly. In fact, it tends to infinity as we iterate the function. This means that z is not in the Julia set of f. If c equal to this, then the orbit of z is. As you can see, the orbit of z stays close to a fixed point and it does not tend to infinity. This means that z is in the Julia set of f. If we see that the number keeps growing and growing, then our chosen point is not considered a part of the set, and it's colored depending on how fast it grows. A number that stays bounded and does not grow, on the other hand, is considered a part of set, and it's colored black. The Julia set of f depends on the value of c, the constant term in the function. Different value of c produce different shape and patterns of the Julia set. Some Julia sets are connected, means they forms a continuous curve. Some Julia sets are disconnected, means that they consist of isolated points or dust. Some Julia sets are very simple, such as circles or lines. Some Julia sets are very complex, such as spirals or snowflakes. Some Julia sets are very symmetric, such as stars. Some Julia sets are very chaotic, such as clouds or flames. For example, here is the Julia set of z square plus c, where c is this. As you can see, it is a disconnected Julia set that looks like dust. And here is Julia set of this. As you can see, it is connected Julia set and it looks like a dragon. There are infinitely many possible values of c and therefore infinitely many possible Julia set. Some of Julia set are very famous. If the point lies inside the Mandelbrot set, then we have the connected Julia set. Otherwise, we have disconnected Julia set. You can explore more Julia sets by changing the value of c and seeing how the shape of Julia set changes. You can also zoom in or zoom out of the Julia set and discover more details and patterns. Thanks for watching. See you in the next one.